It's totally fine. But don't make it, don't make it an excuse, to do the wrong thing. Then you'll be wrong, then you'll be afraid and wrong, right? That's scary one. Okay, Joshua, the number does look weird, right?
It does look weird.
Yeah.
I'm not sure if I did like my steps right though.
The
This says 2 marks here, but
concentration
then I don't know what the 2 marks is for. I'm a bit. Let me check the answer key if you.
Wait, the mole is correct, right? Your mole is correct.
I think I'm hoping. I think so. Should be correct.
Divided by mole. Oh, you forgot one thing. The mole is in dm³.
Oh, the volume.
The unit, yeah.
Yeah. Okay.
You just missed that one. You just missed
Yep.
that. Okay, Nicholas. Now, you have gone through this before. What are we supposed to do here? This is 2 weeks ago. You have 2 options right now. You can look at the previous Jamboard. That's totally fine.
No, it's fine. I will times this part by 18 plus.
I like that. That's algebra. I know that you're strong in algebra. I like that. Good. Very good.
There.
Looking good so far. Looking good. Hey. Where do you get the 6.6 from? Where did you get?
Wait. What did you get?
What are you talking about? How do you get the 74.8? And how do you get the
why?
You times the wrong thing, okay?
18 times I think I times it by 3. So,
I think so. You times by the top one. Yeah, not
why did I times by 3? Why?
The top guy.
Why?
You times it by the top guy. Hey. Good. Okay, Joshua, you okay?
Yeah, I think I'm okay. I think I can. Yeah.
You are definitely, we're catching all the small stuff, definitely.
Yeah, all the
Yeah.
small mistakes. Yeah.
And I would say again, if you want to do more, I'm totally encouraging. Totally. It's up to you until you feel ready. You have to do this sooner or later anyway.
Yeah.
Nicholas, can I confirm that the answer is exactly 7? The one before.
Wait.
Can I confirm that? Is it exactly 7? Or is it 7 point something?
It's exactly 7.
Okay, let me ask you, why is that very good and very important to be exactly 7?
Because X.
I mean, you know that X can be a decimal in other question. In this question, why is it very important to not have a decimal?
Because I don't think you can have a decimal amount of students.
Correct. Only the mean will be possible, but this one, very good. Thank you. Another challenge yet. This is exactly what happened 2 weeks ago. By the way, Nikita, congratulations for overcoming your fear. You are a courageous person.
Good.
Really good. It takes courage to do the right thing. Okay, so don't be too afraid, let's go. Come on, part 2. We warm up for this exact question. We are warming up for this question. This is the tough guy, right? This is the final boss. Okay, guys, excuse me 1 minute. I have to fix my Wi-Fi connection. Apologies, yeah, just a minute.
Sure, sure. No worries.
Joshua, okay?
I'm okay.
Nicholas, courageous person, where are you?
Wait, 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 wait.
Do you need help?
You gotta do something, go something, wait.
Stop doing other stuff, okay? Focus on this one. This is the final boss. Nothing else matters.
And I have to go pee. Isn't it?
Then go pee. Stop clicking stuff. Stop clicking stuff. Go and pee. Come back and face the right. Come back and face the final boss.
Okay, I'm dead back. But may I just ask, can you actually like hear my clicking?
Yes, I can. I'm a bit annoyed
Like-
because I think you're doing some other thing right now.
I have to click because for some weird reason I keep the screen just does not wanna like okay. How do I make it so like
You're not supposed to hold your mouse right now. You're supposed to hold your pen. You're not supposed to pay attention to your laptop right now. Here I am looking at your paper and your pen, and you are looking at something else. It's what I feel right now, because I cannot truly see you, ma. Forgive me if I'm wrong, but I'm not so happy with that. You can take a break, okay? But don't focus on your laptop. Now, do you need some hint?
no.
Okay.
Yeah, the distribution is two. Okay.
Okay.
If the median of the distribution is 2,
You're not doing the thing that the median is supposed to do, right? The mean part of the question, you are reasonably good. The median part, you
Yay!
never, do the thing that you're supposed to do. Like in the first question, I have to remind you, hey, do this, hey, do this. Right. Try to remember that thing that you're supposed to do. I think it'll be helpful.
Oh, crazy. Okay. Hmm. Mm, um, the median distribution is still greatest possible value of X.
You're still not doing what we are supposed to do in the median question.
The median is your middle. So middle
You're
of
still
the
not doing. Yeah, you're still not doing. Come on.
so the median distribution. Wait, the distribution is oh there. Huh? Isn't that this that X is wait, oh, I mean down. Oh, understand. Oh.
Nicholas, do you know that the x from the first part is no longer applicable in the second part?
Yeah, I know. I'm not looking at the first X.
Good. So why are you not doing, the thing that the median question is supposed to do? Like I keep repeating myself, I'm a broken radio, right?
Okay, so
Why- Why don't you do that?
I have to list down the amount numbers, right?
You can do that, or you can sum them up, but do something like that. You can list them down. I think it's not a
So
bad
the social
idea.
networking account is 0, 0, 0, 0.
Nice.
1, 2,
Wow.
4,
Yeah,
5,
okay.
6.
Then two. Okay.
Okay.
Now I will ask you to arrow where the median is. I'm gonna ask you to arrow. The median is described as an arrow.
Okay, that's 10.
Jamboard page 3, yeah? Jamboard page 3. Okay, are you in Jamboard page 3? Arrow, yeah? The arrow represents where the median is. The median is 2, right? You have 5 possibilities. 5. Look. 1, that's your median. 2, that's your median. 3, there's your median. 4, I'm sorry, that's wrong. 4, that's your median. And 5, that's your median. All those medians are 2. Make sense? Am I making any sense right now?
Okay,
Now,
Okay,
continue with your
13,
listing.
16 and 18, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
10. That's 10.
That's 14. Wait, not 10.
No, that's not 14. That is not 14.
No, I'm talking about this part. This the amount is here already. 14 already.
Why is it 14?
No, the amount that's here, the amount of numbers is here.
It's 13. It's 13. What are you doing, Nicholas? It's
1,
13.
2, 3, 4.
Oi,
5,
count
6,
the table.
7,
Count the table.
8,
Count the table.
9,
4 plus 6 plus 3.
I studied now, my bad.
Yeah. You can also count the
13,
table. Yeah, you can also count the
16,
table.
18. Just 18. I need
How did you get
highest amount of-
16? Hey, how did... Oh,
I got 18. Wait, I'm not.
18 plus x, you mean?
No, 18. I'll get 8. Just 18, right? And this is and the one over here is the highest 13. So I get 26.
No, wrong. 25. Not 26. Wrong. If the median is at 13, the total is 25, not 26. You must understand your median is weak. If the total is 26, the median is between 13 and 14. If you don't understand what I'm saying, you tell me right now.
No, I understand what you're saying.
Okay, so if it is 13, the total is 25. Make sense or not?
Oh, yeah.
Okay. Why do you cancel? Oh.
I think it's maybe if I leave it there. So 35 minus 18 lah.
35. Why is it
25. 7. I'm gonna rewrite this. Yeah, there. 20. 25. 25 minus 18 equals 7. Equals 7. 25 minus 18 equals 7. Yep.
Okay, Nicholas, gotta fix your weak median, right? What is the thing that you do in median? Tell me.
Find the middle.
Before that, come on, man. Before that, come on. Before you can find the middle, you ought to help yourself by
Finding the amount of numbers and dividing it by 2.
just list down the number. Why is it so difficult? That's the thing that helps you right now, right? You list down the number and suddenly you can think clearly. Correct or not? You list them down in order is what helps you think. Do you
Then I
understand?
don't know the amount of x's. I don't know the amount of 3.
Nicholas, I'll just say to this one more time, okay? You want to listen to me, it's up to you. You don't want, it's up to you. When you list down the 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, 2, that is where you start to do the right thing. That is where things are helpful. That is when you start to think. After you list them down in order, you can think. Before that, your thinking is haywire. Tell you a secret. My thinking is also haywire if I don't list it down. I am just as smart as you, nothing more. I need to list them down one to think. Now, if you're smarter than me, you go ahead and don't listen. You go ahead and think immediately. I am not that smart. That's why I can tell you immediately. I know how smart I am. Not that smart. I know how to help myself. Okay? You want to listen to me? Up to you. You don't want, just be careful of median. Your median is weak. Model, please. Your model seems strong.
Okay. The most amount, right?
Joshua, you okay?
The most amount, the one has 3.
We
The
can
smallest
move on
possible
from.
value is 7.
Fair enough.
I think we can move on from mole.
Okay, got it.
I think I'm okay. I'm getting it already. It's
Good.
back to me.
Right.
Yeah.
Please wait for a while. Let me check.
Yeah. No. Yep. Sure.
Is 3
Un-
status small?
Unfortunately, sorry. Unfortunately, the pages 3, 4, and 5, 6, 7, basically. Only two only is the only one that has the answer key. The rest, I think, doesn't have any. Yeah.
Really?
Yeah.
Okay, but
I tried looking for. I typed mole, and then I the control F, right?
Yeah.
I went down, and then there was no. Yeah.
Okay, I better check. I understand, Josh. Just wait. So Nicholas, you are correct. Definitely 7 is the correct answer. Good. A strong move. Okay. Is this the end? Is this the final boss?
Yeah, that's the final one.
Good. Now, has your teacher moved on from this chapter or not? Hey, has your teacher moved on from this chapter?
There's no more anymore, so that's
No, I mean in class. Has your teacher moved on? Are we still in this chapter for what, 4 weeks? It's crazy, man.
no. You're moving on to new chapter.
But not yet, is it? You're going
Yeah,
to.
we already moved on to new chapter that we just started.
Okay. Do you have your textbook with you?
Actually, yeah, I do have my textbook.
Very good. Every time in tuition, we have textbook, okay? You're going to do what good students do. What good students do are very simple. They prepare for the chapter before the class. Okay? Now, open to the new chapter and you're going to read and do questions from the new chapter, even though you haven't studied them yet. That is
We
what
started the new chapter. It's just that we haven't started long enough.
I understand. Shall we do it then?
Yeah.
Textbook, please. All right.
Yeah, find the what. So what chapter we want to get?
No.
We are on
Joshua, don't mind, Nicholas. Yeah. So, Joshua, we are doing some form of thermal
we're
physics.
doing congruent figures.
Okay.
Of that.
Yep. Okay. Sorry.
We're doing
So,
congruent
in
figures.
page 7, yeah.
Hmm.
There are only two formulas to understand. Once you understand how to use them, the thermal chapter is almost done, at least the later part. The initial part is not very difficult one.
Hmm.
Okay, you'll face trouble explaining, but that's just fixable by practices lah. And to get practices, you must understand the chapter. So Q is your heat. Heat in a form of Joule, okay? Because it's thermal physics.
Thermal energy. Okay.
Okay, so okay.
So thermal physics is interested in the movement of energy. So
Yeah.
it is a continuation of the work energy power.
Yeah.
What is the movement of energy? The transfer of energy, right?
Yep.
Remember,
Yep.
transfer from
Mhm.
your wallet to your ATM source. Heat is the other way to transfer energy. There are only two ways: by work or by heat. It's very simple. They are
Heat
actually
is a energy store, right?
no. Heat is in the form of transfer. Heat is a transfer. Let me
Oh.
repeat
Oh,
this.
yeah,
It's
yeah,
not your
okay.
wallet. It's
Yep.
not your wallet. It's not your ATM. It's not your bank account. It's the movement between them.
Okay. Yep.
Yeah. Once you fix that, things are going to be easier, lah, right? So,
Okay.
M, you know, that's a mass, right? Delta T, you know, these two things are good.
Delta T is difference in
Uh,
temperature, right?
Correct. So
Okay.
the more different the temperature, the more movement you get. I mean, a movement between a very cold and very hot item will be a lot.
A lot of work.
A lot of heat in this case. Heat.
Yeah. Okay.
Okay. Just a minute, Nicholas. I'm seeing that you're looking at question 6. Any particular reason? I would like you to.
No, it's just it's zoomed in. I cannot really move it.
Okay, so what I want you to do is, Nicholas, so you look at a section of the chapter that you don't know very well yet. Obviously, because teacher haven't covered. I want you to go to that section and do one question, and I'm going to help you do that. Because, of course, I know you are still learning. We're going to do it together. You understand? You are going to take initiative and choose a question that you don't feel absolutely confident. I want you to summon the courage you have just now. Choose one. I'll take a picture and then we'll do it together. Okay, so Joshua, this is called latent heat. Don't know why.
Latent heat. What's
Specific heat.
okay.
Something here. Specific heat capacity. It's, however, a very simple thing. It's a very simple thing to understand.
Okay.
The famous graph. Solid. When changing from solid to liquid. Now, this will be your temperature. This will be, let's say, time. Time is not in the formula. Just say. Which one, Nicholas? Have you chosen one? 6, is it? Sorry, you chose 6, is it? 5, is it? Sorry, which one do you choose?
No, I don't know. Congruent figure is literally just angles, eh?
No,
Okay, what this one?
Choose one.
I think I find this one.
Choose one. Which one? Show me. Which one? Question 4. Question 4, is it? 4. Is it 4? Sorry. 4. Okay, I'll take a picture of 4. Yeah? Move up a bit. Sorry, move up a bit. Yeah. Okay. Wait. Okay, nice. Thank you. Oh, sorry. One more time. Sorry. I messed up. 4. I'm messing up. Sorry, I'm messing up. I am being very slow. I'm sorry. Thank you. Okay. Done. Thank you. Sorry for the wait. So I'm pasting it in the Jamboard, and then you go and take a piece of paper. I think better, yeah. Unless you want to write directly to your book, right?
I'll see the Jamboard.
Okay, so I put it in the Jamboard first. There you go. Okay, I'm putting it there. Now, if you could, you do it immediately. If not, I'll start to give you hints. Okay, start to give you. Okay, on paper,
Okay.
on book is also fine. So Joshua, yeah. The understanding of physics here is extremely simple, yeah. When you are heating up something, apologies, I need to get that. When you're heating up something, the temperature will rise. This is represented by the formula, the first formula, and this part of the graph that says you're increasing in temperature, right? That's the easy part.
From solid to from the solid state and then to the solid to liquid state, right?
Correct. So
Okay.
when the solid is still solid, no? When the
Mm.
solid is still solid.
So that's
So therefore,
the specific
the-
heat capacity.
That means there is a specific heat capacity for whatever material is there. So if you're heating up a metal, then specific heat capacity of metal. If you're heating up water, specific heat capacity of water, they will give you one. It's just a number that they measure and they use. Okay. Now here's the kicker. Even in water and ice has different specific heat capacity. So if this is ice, you will have a different heat capacity than water because that's just in the nature of stuff. Okay, so specific heat capacities are very specific. Pardon the pun. Okay, you understand?
Okay.
Yeah, good. Now, what is interesting is when you're starting to turn from solid to liquid, you will need a lot of heat also, and that the first formula no longer works. It will be the second guy. Physics-wise, in reality, when ice changes to water, finally, when ice goes from, I don't know, -5 to 0, during his liquefaction, during his melting, it's always 0. It's always 0. When ice is melting, it's always 0. He keeps absorbing heat to melt himself. He will not increase his temperature while doing so. That is the physics and the reality. Okay, am I making some sense? Because Joshua.
He will keep taking in heat.
And
So
use it to melt himself.
So
but
he
will
doesn't
not-
gain the heat then. It's just
No.
using it to melt it.
No,
Okay.
he's gaining. He's not gaining temperature. He's gaining heat. He
Okay.
is gaining
All right.
heat.
Okay.
He is
So like
receiving the transfer.
the thermal energy is used to convert from solid to liquid,
Very good. Not to raise the temperature,
not to raise the temperature. Okay.
but it is being used. The transfer is happening.
Yeah. Yeah.
Okay. That's it. This is the heart of the chapter. At least the last part. Okay. At least the last part. Now, my challenge to you is very simple. Go and take one thermal question from paper. We're going to do it together. Nicholas, for the congruent one, do you know which one's which, right?
I don't know how to explain.
I can.
Yay!
So congruent means exactly the same. Exactly the same. However, you can rotate lah. I mean, I agree that it's not fully exactly the same, but if you rotate this, it will be exactly the same as the first one. How do I know? 3, 3, 4, 4, 5, 5. The angles are also exactly the same. Only the name is different. In that case, A is definitely congruent with each other. Am I making any sense right now, Nicholas? Am I making any sense right now?
Baby. Yeah.
Okay, you're sure, right? Because your mic is very bad. Huh? Okay. Now, option B lah. So are they exactly the same if you rotate them lah? Are they? Let's see. 19, 97, right? Okay, it's the same. And then 18 and 18. Well, that's the same. 10 and 10. That's the same. 80 is between. Are you okay? Are you following me, Nicholas?
Yeah, of course.
80 degree is between 10 and 18.8. Well, that's the same. Correct? That is the same. But now we are left with 70 and 30. You have to make a decision here. Look at the 70 degree, look at the 30 degree. Are they the same or not?
Sorry, I can't find any questions.
Okay. Then
I don't have any physics.
No. Oh, you don't
Yeah,
have.
if you
Really?
don't mind sharing,
My goodness, I better fix that mistake.
if
Right?
you don't mind sharing, I can find it.
Yes.
Thank you, thank you.
Nicholas, how are you going to deal with 70 degree and 30 degree?
Okay, the first one is definitely a congruent triangle. Definitely a congruent triangle.
The first one is, you mean option A, is it?
Yeah, it's definitely a congruent triangle. But then the second one,
Yeah. 70 and 30 is your problem right now. Got to solve that problem. What do you think? Are they the same or not?
I
Because
think,
obviously 70 is not
wait.
equal to 30, right? Obviously lah, but
Okay, wait. I'm
how do we decide here? How do we decide?
done this.
You can turn it. You can redraw it. You can do that. Yes. Okay, I shared Joshua. I'm so sorry, I shared the wrong. Sorry. Sorry, Joshua, I shared the wrong one.
Wait.
So what do you think?
I mirror this.
Mirror. No, I'm sorry, you can't. No, I'm so sorry, you cannot. But you can just, I know what you're trying to do. Okay, let me do something for you, Joshua. Okay, Nicholas, let me do something for you, right? Oh dear. Okay. Sorry, Nicholas. Don't clash. Stop doing stuff. Let me do it. Let me do it. We don't clash. We don't clash. We don't clash. Right, there you go. Then we'll do that. Yeah. Okay. You can't mirror it, but you can turn this lah. Are you happy with that? Do you want that? Do you want that? Is that what you want?
No. Because you see, this one is mirror. Wait.
You sure or not?
Mirror.
You sure or not it's mirrored?
Wait.
You sure it's
No.
mirrored?
Wait.
So Joshua, I shared with you O-level physics, right? I shared with you another wrong folder, so you just ignore that for now.
It's quite wrong.
Are you sure it's mirrored? Are you not
No, it's
just
not.
complicating stuff, right?
No, it's wrong. Completely wrong.
So is it mirrored or not?
No,
Okay, good. So it's easier, right? So what do you do?
it's wrong.
Okay, so I have a news for you. Oh, sorry. Okay, there you go. Okay, this is 70, and this is
It does not look like 7. It does not look the same. No. It does not look the same.
they are exactly the same. What are you talking about? Just look at it. Don't move stuff.
Oh, right. Look. It looks way different from this photo. Hey, I don't know already. I'm thinking.
Hey, Nicholas, I said something. Pay attention.
Wait.
Focus on my words. Focus on my words. Focus on my words. Stop moving stuff. What is this? What is this? Tell me. Focus.
70.
What is this?
70.
What is this?
30.
And what is this?
30.
How do I know this is 30 and this is 70? How do I know that? How did I do that? Did I just copy? Is that what I did?
Obviously not.
What do I do? What did I do?
Oh, I'm so dumb. Oh.
Correct. But because you understand, you're not dumb now. Just now, a little bit brain block lah, huh? But now you know. You understand me? Okay, now do yourself a favor. Copy paste page 5 to the next page of the Jamboard. You can do that by yourself, by
Copy paste
referring to
what?
your own video. You show your question 5 in the video, right? And then you can just screenshot that question and put it in your Jamboard. Okay, let's continue. Okay, let's continue. Joshua, are you okay so far? Are you able to access the Google Drive?
I am able to access, but I don't know what keywords to use to find it.
Fair enough. So let me help you, right? I mean, it's new. Yeah.
Sorry.
I guess temperature will be a
Okay, temperature.
will be possible, but only if the PDF is searchable. It might not be searchable.
Okay, yep.
You may just scroll down, but it's usually kind of easy. Can be fine. What can be found. Okay, so Nicholas, to help you, this symbol means congruent. Right, congruent. That is that symbol. The congruent symbol.
There are 3 lines.
Yeah. Okay, so by that, we know that the two triangles are the same lah. However, they are mirrored lah. They are mirrored. Still the same, but mirrored. You can see that, right? Now here's your mirrored triangle. Okay, now because they're exactly the same, they already tell you, right? So you can use that law to find out whatever they want you to find. Please give it a try. Okay. Okay, so Joshua, I'm looking at 2020, the first paper, so Baccaro, for example. Thermocouple is part of it, but thermocouple is not what I talk about just now, so you're going to ignore that for now.
Okay.
Thermocouple also not very complicated, so you'll see later. So I'm taking from the first paper from MCQ, right? Okay, I'll give you examples. You don't have to erase the thermocouple one, just leave it there for now. Okay, so for 15, 15 is a continuation of your Sec 2. So 15 is not going to be difficult for you.
Oh, okay.
16 and 17. You just look at it for a while and then we'll discuss it. So Nicholas, tell me, what's angle BAC? Have you thought about it?
BAC is 60. It's 180 minus 2 minus 62.
Which is?
Six.
Okay, let me clarify a few things with you. This is 90 degree and this is at 62. Would that be okay?
Yeah.
Right. So you can do half or you can do the full one. So 180 minus 62 times 2 lah. If that's what you're thinking, then you're correct. Okay. Because your mic was bad. Okay. Are we clear here?
Yeah.
Okay. Now how about the length of BC? Come on, part 2.
The length is 16 lah.
Wonderful. Got it. Basic stuff. Good. If you find this not very challenging, you can jump questions. Choose your questions and let's do it together. Okay, just one. So although your answer is possible, Joshua, I must admit lah, Joshua, possible until you realize a pot made of a very good insulator material cannot be heated very well lah, until you realize that.
Yeah, okay.
So
That's fair, that's true. Yeah.
it makes sense if you're talking about not cooking with it. It makes sense if you just talk about storing it.
So does that mean it's a high specific heat capacity?
Because high specific capacity has a connotation of being able to store many heat, which is the right connotation to think about.
Okay.
So the pot is hot for a kind of a long time because he is able to store many heat with himself.
Okay. I get it. So heat capacity is like your how much thermal energy you can store in one instrument.
One, in one temperature, but you understand it later. Like that's the right way of thinking about it.
Okay, all right.
Yeah.
So it should be A, right?
Yeah. Again, not because of B is wrong, but it doesn't make sense. Right.
Okay.
Okay, Nicholas, what's your next choice of question? Give it to me. Come, one more, please. One more, Nicholas. One more. Let's be a good student one more time.
Yeah, I'll try one more lah.
Okay. You can choose as hard as you want or as easy as you want.
Oh, I do
Up to you.
6. I do 6 already there.
Let's do it. Let's do it. But help me and paste it lah.
Oh, wrong one.
Okay, so I hope Joshua, this one is wrong because you know there should be this line, correct?
And then
A is also wrong because their
Wait,
gradients
no.
are both the same.
yeah, it should be B.
Okay, so B
Is it-
this is faster, correct? This is faster and this is slower to raise, correct?
Yeah.
The C is the other way lah. So because ice has lower specific capacity, surprisingly,
It should be
it will
faster.
increase faster. Yeah.
Okay.
Correct.
Okay.
So
Makes
you're already
sense.
getting a very good sense of it. Right? It's a good sense. Those are good senses.
Okay.
Maybe get one more lah. Just try yourself. Try finding one more. This is only from the first paper of 2020. Already quite a lot in the MCQ. Right? Maybe you go to paper B or you go to another MCQ. Right? And then give it a try, and it's a good day. Good, Nicholas. They tell you that it is congruent, right? That is a good day to live if they tell you that it's congruent. Okay? Congruent. So, do your stuff, please. Can you do it by yourself? Okay. I mean, maybe you use your mouse. Now is the time to use your mouse lah. Click stuff and write stuff in your Jamboard, or you can write it in your textbook. I'm totally fine. Do something, please. You have 1 more minute. Come on.
Okay.
Paper or Jamboard? Nicholas, paper or Jamboard?
On paper. I'm Jamboard.
A Jamboard is fine.
Is something like this okay?
Looking at it, that does look like a thermal question. Yeah, and they get you specific heat capacity of water.
Yeah.
The power is the, if you don't know what's power,
It's
you can
rate
ignore it.
of work done, right?
Yeah, rate of work done, rate of energy transfer lah, basically. Rate of energy transfer lah, right? Which is very applicable. Power is the easiest part though, so you focus on part 1 if you could. If you cannot, nobody's gonna laugh at you, right?
I mean, the average mass of warm water required to maintain the indoor temperature at 25.
Nicholas Adelio, do something, please.
Yeah.
Come on, do something. Let me see something. Click your mouse.
I don't know how to start from here.
Of course, let me show you.
So if A, B, C, and D, C is congruent, one, and A, B, C, right? A, B, C. It's 70. This one is 75. Okay, the length of B.
Oh, wait, is the 200 megajoules?
It's going to be.
Is that the latent heat?
So no.
Oh no,
This
that's
is,
your yeah,
Q
that's
out.
your Q.
Okay,
Yeah.
there, I got it done.
Okay, okay.
Let me see, just a minute. The colors, nice, yeah, nice.
Okay,
nice
now
colors.
it's just to reverse it. Q equals to C and then there's one more. MC difference in T, is it?
Yeah, just a minute. Yeah, so very good, Nicholas. Okay, I'm quite happy that you are now slightly ahead of class. Are you ahead of class?
A little bit.
Good. A little bit means you're a little bit of a good student. That's how it feels. How do you feel?
I'm feeling good.
Good. As expected of a good student. Good, my courageous and good Nicholas. I will see you next week. Hopefully no longer statistics. Oh, please. Right? I'll see you. Bye-bye.
Bye.
Okay, Joshua. So you're right, because we need to let the water queue out lah. Yeah, the water will be,
Yeah.
the water will. This is a warm indoor to maintain the temperature. This
And
is it's
just
winter lah.
over.
It's just winter ma. Yeah, because it's winter ma. Yeah, correct. Yeah.
So it's 45 minus 25, right? To get the difference in temperature.
Correct. Because you cannot allow it to drop to 24, so to speak, right? You can only allow the water to drop to 25.
Megajoules times how
Power
much?
6, 10 power,
Power
6.
6, 10 power 6.
6, so just, yeah, everything just 10 power 6. It's okay. Just write down 200.
210 power 6, yeah.
And you'll get the mass in kilogram lah. Yes, I need it.
2 times 10, 3. 20, 110, 6. Should be 0.0042 kilograms. That's what I got.
Which is a very small number.
Yeah.
Oh, goodness me. Because your algebra is all wrong.
Wait, is
You
it?
have a math problem.
Oh no, other way around.
Yeah,
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 flip.
try again. And then you check the answer key, yeah? And then well, I dare say quite a good job for today.
10, 6, 4.2, 10, 3, 20 equals to m equals 2. Just flip this around. 6, 4.2, 10, 3 times 20. 2,380.95, which is essentially 202, yeah, kg. Okay. I should be done.
And you check the answer key.
Okay, let me check it. It's question 11. BCS. Yeah, that's right. Yeah.
I hope you have a good taste of the thermal one.
Mm.
You already know that this is an exam level question, even though Barker Road is supposed to be the tier 1, but it's still exam level. It's still hard to understand if you don't use your logic. You were using your logic quite.
Yeah.
Okay, good for you. and I will see you next week.
Thank you. Bye bye.
Bye. Kyoko, I can see you. Can you hear me?
Yeah.
Okay, Kyoko. Updates, please. Updates.
We did a few circle properties questions in class.
Oh, yes. Mhm. Go ahead.
And my teacher asked me to do GYS as practice for all the chapters.
Yeah, easier said than done lah. But of course, he means starting to do, right?
Yeah.
Which is you're already starting, like somewhat, lah,
Yeah.
right? Somewhat, right?
Yeah.
Now, let's be clear about what your teacher asking you to do. Your teacher asking you to revise, right?
Yeah.
You better prioritize lah. You won't try to say revise everything for prelim. That won't have time on. You have to have priorities before prelim and priorities after prelim. Prelim is not O level, okay? If you try to do everything before prelim, then you are either sacrificing other subjects, which is fine with me if that's what you want, or your other subjects are extremely good. Okay? If that's the case, then I'm very happy to help you to revise everything before prelim for AMAT lah. Very happy. Okay, or you will burn yourself out before prelim, which is a total nonsense.
Yeah.
Okay. Let me tell you what happened to your sister. Your sister is not a comparison. I mean something like this. Your sister doesn't score very well for her mid-year just now. She scored chemistry 51%, 51 or 52 lah. Do you know what happened? She is still the highest in class. And she almost reached her goal, and she did improve on certain aspects of chemistry. That's just chemistry. She obviously have a lot of ways to go, obviously, right? Because especially her goal is A1, just like you, A, right? But she can do that a little bit more before prelim, and then the last step after prelim, before O level. The point is, in her mid-year way of studying things, she improved in her specific goals, and as a bonus, she is better than her class. That means she's doing something correct, something like that. You, Kyoko, what do you want to improve for your prelim in AMAT? You must be very clear, it cannot be everything. Okay? It cannot be everything. Yeah? Before you answer that, before you answer that, okay, Trigo is fine. I like Trigo. But before you answer that, do you want to talk about that first, or do you want to talk about your homework first, which is the circle property? Which one first today?
I think I don't have homework for circle properties.
Oh, you don't have problem with circle properties.
Yeah.
Oh, that's nice. I like that. You sure?
Yeah, I don't have.
Okay, sure. Shall we talk about simple goals for prelim AMAT? Then you can know how to revise. Okay, let's go to your Jamboard. Before that, Andrew, I can see you. Can you hear me? I cannot hear you very well. This is very weird. So your voice is there, but there's a lot of digital noise behind it.
Oh, sorry. There's a plane flying over right now. So.
Must be the reason. Okay, let's wait for that. Okay, so Kyoko, I'm just using the previous Jamboard. So Andrew, try again. Can you hear me? Still have that noise. Okay. Okay. Maybe like this first. So Andrew, your Jamboard is almost full. Maybe you create a new Jamboard and share with me first. Maybe, yeah.
Wait, can I?
Oh wow, Kyoko. Yeah. Yes, Kyoko.
Can I get water?
Yes, Kyoko.
Okay.
Yes, please, Kyoko. Right. Yes, hello. Ines, I can hear you. Can you hear me?
Yeah, I got a bit of a bad throat, but yeah.
Should we speak less?
Possible.
Okay. Check one more time. Okay, understood. Yeah. So, Andrew, is everything clear there?
Yes, I'm doing the Jamboard right now.
Oh,
Setting
yeah,
it
yeah,
up.
it's good. It's good. Now I can hear you. Yeah, good. Right. So, Andrew, what are we doing today?
Chemistry, haven't had lessons. Had lesson, but I didn't cover anything new. But for physics, I started the energy work power.
Which means you're not having any problem right now.
No.
You might have problem later because it's very slow.
Yeah.
Okay, then.
I'm still just a bit unclear about the wording because the new energy store wording and everything.
You can ask questions on that. Do you want to clarify that?
Okay.
Which Jamboard are we using? Okay, for Ines, this is going to be a math day. Any objections if we continue the binomial?
Okay, but tomorrow can we do OChem? Because I'm gonna go to school tomorrow, and apparently she's teaching OChem and no one understands. So I'll see first. And
You
then
don't,
if I'm
sorry,
confused.
sorry. You don't understand, okay? Sorry, what are you saying?
No, I haven't gone to school for the past 2 days, but she started OChem and all my friends say they don't understand.
I
So-
think you will have a good news tomorrow, okay? So tomorrow you look at it, and
Yeah.
of course we can discuss that, of course.
Sure.
Continue binomial. Review your Jamboard, please. I was not happy with your notes on binomial. You try to improve it. Please read it because the questions will not get easier. You got to read your Jamboard first, okay?
Yeah.
Okay, please give it a try and please ask questions, right? You may trigger some questions.
I
Yoko,
just sent
just-
the Jamboard.
All right. Okay. I'll access. Okay, and do chemistry too. Sorry, chemistry too. Sorry, do you want to talk about chemistry today?
We
can, I guess.
No, I think I'll prefer if we talk about physics.
Right. So will you be confused if the Jamboard title is chemistry? It's up to you, but will you be
I
confused?
think I'll just change it to science.
Please do. Right. Okay. Are you going to paste questions or show me something? Kyoko, are you back? Ines, are you in the Jamboard? Not yet, huh?
I'm back. Yeah.
Right, Kyoko. Okay. So glad to hear that your circle properties are doing well, by the way. Yeah? Okay. You did say that you improved Trigo at prelim. Okay. I'm writing in page 8, right? I agree with your choice, partly because Trigo is a lot of marks, of course, and Trigo is very heavily used in integration or differentiation, which is, the later chapter. So I agree with you. Now, maybe my request is you put Trigo and polynomial also at the very, because you have revised polynomial. Then there must be some goal in that, because if not, then why bother revising? Makes sense, yeah. So Trigo, you need to specify per topic. At least that's what I believe. Then you'll be a bit clear about what you want. Okay. I'm going to help you right now. I'm going to help you by listing down the sketch. The sketch one is minimum 6 marks. Okay. So this is the minimum of the question itself. Okay. Not your goal, right? Sketch and then you see, right? Okay. If you could specify a mark or specify something qualitatively. That means either you say mark, sketch, or maybe you say, I want to be able to sketch quite quickly, or I want to be able to sketch a combined graph, that kind of thing. Anything specific is better than just say want to improve the ego. Do you understand what I'm saying? You cannot just say, I want to improve my R formula. That is of course correct, and you're improving it. But what do you mean by improve? You want to get full marks? You're going to get 7 out of 8 marks? You want to make sure that the first part you can do? You want to be able to do it fast? What do you want? Now, are you confused with what I'm saying?
No.
Okay, then please be specific in what you want to improve. Will that be okay?
Yeah.
Can you do it now, or you want to look at the question first before you decide what to improve?
I don't know.
If you don't know what you do, then I would suggest that you look at the 3 core questions first again, right? Okay, and try to do 1 or 2. We have some revision, and then by the end of the day, you'll be able to at least specify your goals. Okay? That be okay? Now, if you're doing that, please take a picture of the question and put it in. Anesh, are you okay with your notes? Since you are not at a specific page, okay, I see that you're in page 6. If you're okay, do indicate to me, maybe type something. If you're not okay, you gotta find a way to tell me also. Now, Andrew, are you going to show me a question, or are you going to, what are you going to do?
I think the questions I can manage. It's just that when teacher explains the question, she talks about kinetic energy store, then into the potential energy store or something.
Okay. Let me clarify that. Let me try to clarify that. Okay, in page 1. Now, the first thing in the chapter is work. And I tell you at the start that work is very similar to money transfer. That means it's a transfer from something to another something, right? I'm asking you to imagine that one of them is your wallet and the other one is your bank account. I know that you don't have a bank account, but just imagine. Okay? Your wallet will be of kinetic energy, and this one will be potential energy. Your teacher will say that potential energy is storage, implying that kinetic energy is not storage, implying. Okay? I mean, in some sense, your bank account is a better storage than your wallet, in some sense.
So I do not say kinetic energy store, I just say kinetic energy.
No, you will say that the kinetic energy is stored as potential energy, meaning there is a transfer from kinetic to potential. That's actually what it means. Okay. They don't prefer the word transfer, but that is the most proper understanding. Kinetic energy has transferred into potential energy. Potential energy is called storage. So I guess you can say kinetic energy is stored as potential energy. I guess you can say that. What we understand of that is kinetic energy transfer to potential. Okay. There's a reason why I put wallet as kinetic energy, because in your wallet, money tends to be spent, not stored. You can argue that wallet is the function of wallet is to store your money. Not really true. Wallet is the function of your wallet is to bring your money in order that you can spend your money. Wallet is not a true storage. Bank account is more like a storage, or piggy bank if you want. Either way, nothing. Okay, so that's just to help you understand why they think like that. Because it is true that kinetic energy is not so much of a storage. Potential is more of a storage. Okay, so far so good. That is one of your concerns, right?
Yeah.
Okay. Oh, goodness me. Kyoko, you chose not the challenge, not the, you chose a rather unique question. Huh? You did that one, you did. Anish, tell me something. Are you okay or not? Write something
I'm
for me,
still
please, right
reading.
now. Okay, I understand. Okay, so Andrew, there is also proper transfer from kinetic to environment, to anything else, environment, right? This is also transfer. Work lah. Okay, transfer. Transfer out. Like you spend your money in your wallet and then it will become something else lah. So transfer as heat, transfer to what, transfer as sound, whatever. But that's transfer. That's never a storage. A sound is never a storage. Heat is never a storage. Friction is never a storage.
So
Never
you
done.
cannot directly transfer like heat from the storage? Like
From PE, very unlikely. PE will need to become KE
Then
most
transfer
of the
out.
time, and then transfer. Then
Okay.
your or some people, some person will say lost lah, lost, which is a transfer, man. A transfer lah, still a transfer. Your money is lost. No, your money is transferred to the iPhone seller. The iPhone is transferred to you. Okay, fair enough.
Okay.
But in reality, obviously, you can transfer from your bank account to his bank account. That's in reality.
Yeah.
Here, we pretend that, no, you'll go through your wallet. We just pretend that for now. Okay. Have I clarified most of the things that are confusing?
Yeah. I actually found a question. I'll
Yeah.
just put on my camera.
Uh-huh.
It's the example 4.
Okay. So Andrew, today is a bit crowded, so you gotta help me screenshot and put it in your Jamboard, okay? In case
Okay,
I'm
got it.
okay.
I'll do that.
In that case, Andrew, I need to explain one more thing. Sorry, yeah, we go back to the slide. Just one more thing. Okay, there is somebody who do the transfer. There's always a who. The who is the force. Let me repeat this one more time. There is no transfer without force. When a transfer happens, a force must be doing it. A person must be doing the transfer. You, for example, or your father, or the seller, or a thief, whatever. In physics, the transfer will be a force. So, for example, a transfer from potential to kinetic, the usual transferer is gravitational force. Gravitational force causes you to be able to change PE into KE. So it's the work done by gravity. The work done by who is doing the transfer. Am I currently making any sense? Okay.
Yeah, I get it.
This is in the direction of this one. So to show you that it matters. Sorry, I'm having a bit of a problem. I am having a little bit of that. Okay. So to show you that it matters who, the transfer the other way around is definitely not gravity. Definitely not. When you transfer KE to PE, for example, you're lifting something up, right? That is usually not gravity, not gravity at all. That is not gravity, but it is F by somebody. Somebody throwing it up. That's not gravity. Somebody lifting it up. That's not gravity. Do you understand what I'm saying?
Oh, yeah, because the force applied by the person.
Yeah. Yeah. And a force applied by a person usually do not change PE to KE by KE to PE. Usually, not all the time. And gravity will do PE transfer to KE, not the other way. Definitely not. So the who actually makes a lot of sense. Okay. So the transfer from KE to heat, you know who's the who? Friction, ma? Right? That's the culprit. Correct? Friction. For example. Okay. So the who matters a lot in this chapter. They just don't present it that way. I noticed that a lot. Okay, just want to say that. So yeah, go ahead. Put your question.
Beautiful.
Okay, Kyoko, would you like some hint, please? This is not the first question we want to do. Definitely.
Yeah.
This is difficult. Okay, look, let's not demoralize ourselves. Let's do something else first, and then we'll come back to it. Okay, I promise. Okay, I promise.
Okay.
Promise you that. I promise you. Okay,
Okay.
promise you. I will let you do this yourself. I promise you. But later, later. Yeah.
Okay.
Looks so tempting, right? 2 marks. Looks so tempting. Ines, are you okay so far? Uh-oh, Ines is gone from the Jamboard. Uh-oh. Uh-oh dear. Andrew, you're still plugging your camera, yeah? Okay, understand.
Wow, I thought I was gonna take a photo.
Sure thing. You can take a photo using, I don't know, WhatsApp, I guess, Go WhatsApp app and then just put it in the Jamboard. That also works. Ines, you're back, yeah? Ines, you're back. Just now I lost you, yeah?
Yeah.
Okay, good. Are you okay? You're back to the Jamboard. Good.
Yeah, I should be okay. I feel like such a question.
The question, we can continue. The question will be the one that we have not finished, right? That would be page 11. Please confirm that the page 10, part 2, you are done.
Yeah.
Okay, then I guess we are left with, but you did page 9. You did that. You did page 9. Okay. Let me confirm that there's nothing else. Oh, goodness me, there's the hardest one. Okay, I'm moving the hardest one behind. Now it is page 10. Please go to the new page 10. Observe for a while, Anish. For part B, I'm asking you to observe part B or what? This is the first time you see the power as unknown, correct?
Mhm.
Power unknown is the most difficult version of the binomial. I'm gonna ignore this one. You're gonna need some notes there. For part A, it's a totally different question. Part A, you're supposed to be able to do this, even though they look complicated. Please give it a try. Remember, yeah, general formula immediately separate into coefficient and power. That is your standard step.
So tedious.
If you don't want to do it, we'll just do a new topic. Okay? It's up to
No,
you.
do it.
Thank you. Kyoko, are you stuck so far?
Yeah.
What is this topic?
Formula.
Right. Are you stuck with part 1 and part 2?
Yeah.
Then you're wrong because part 3 and part 4 has more marks than part 1 and part 2. You're not supposed to start in part 3 and part 4. Do you understand that you can do part 3 and part 4 immediately?
Yeah.
Then do that first. In an exam, you do that first. Stop being stuck in part 1 and part 2. Right? It's not good for your morale. Bad morale, bad. It's just bad. Okay? Okay, Andrew, what's your question here?
I just don't really get how in the equation work done you can just suddenly get GPE, and there's another equation. I thought work done was force times distance, so I'm a bit confused. The rest of
One
the
more time.
calculations, I get it.
One more time. I know that work done is force times distance. I know. This concept is the transfer, correct? The transfer is done by somebody who transfers along a certain distance. Okay, that's how we understand this one. Okay. So far, so good.
Okay.
This formula is not what I teach you first. What I teach you is what transfer means. Transfer means from one form of energy to another form of energy.
Yes.
Yeah. So one more time. Just by looking at the start and the end, you know that the GPE increased. Okay.
Yes.
The KE stays the same.
Increase. Oh, still.
No, no,
Oh,
no, no.
constant.
Wrong. So it's the same.
Constant speed.
Correct. So no transfer. No transfer in and out of KE. Correct? Got
Yes.
transfer in. This is got transfer in. Got transfer in GPE. From where? From where? Not from KE.
The force F.
Correct. The force F is the one doing the transfer. Okay. So let's pretend that the force F is somebody lah, from somebody lah. From somebody. Because the force must be done by somebody, so somebody lah. Correct. It's not done by the KE. There's no transfer from KE to GPE. Okay.
Okay.
Then there's friction some more. Friction is supposed to, what does friction supposed to do? Friction is supposed to transfer out of KE. Supposed to. Friction out. Friction's job is to transfer KE out into heat. Okay, how come the KE stays the same? There must be a transfer in. Correct. There must be a transfer in also to KE in the same amount that the friction transfer out. So the transfer in will be equal to GPE increase and this. That will be the equal to the transfer in. That's the total transfer in. Am I making any sense?
Yeah.
That is the first thing I teach you, not the formula.
But wait, why is it labeled as work done then? Why not just change in energy?
Because work is change in energy. That is the most proper definition of work. They just call it work. It is transfer. Work is a very confusing word to use here. What it means is transfer in or transfer out. Transfer lah. I agree with you. The words are confusing. That's why I keep telling you what it means. I keep explaining to you what it means. I cannot do anything about the choice of word. You cannot, but you can do something about your understanding.
Okay. Got
You
it.
understand me, Andrew? Okay. Now, please, do you need to redo this or something?
No, I just copied. This one's just copied. I'll look through it one more time to get a better understanding.
No. I want you to do it by yourself. Close the answer. Close the answer and try to do it. Kyoko, are you okay so far? Okay, you started from this. Are you stuck currently, Kyoko?
No.
The starting is fine. Okay, Ines, I can see your phone. Right. And do just to confirm, you want to do it on paper or on Jamboard? That's totally up to you.
I'll do it on paper and send a photo.
Sure thing. Yeah, this part you know you can do it, Kyoko. Good, good, good. Okay, Ines, how do you start question this? How do you start? The most standard way possible. According to your note, what's the standard thing to do?
To do separating coefficients.
Yeah, but before that, general form.
Yeah.
Then you separate. So please, general form and then separate them. Doesn't matter what the question is. That's the first thing that you do. Okay, Kyoko, keep it insert form, yeah? Andrew, are you okay so far?
Yes, just getting my paper.
Sure thing.
What? I don't understand this picture. Man,
Which one are you talking about?
page 5.
In page 5. Page
This one.
5? I'm sorry, which one are you talking about? You don't understand your own writing?
No, as in like, you see this one, right? You got 12 CO, and over here, there's no 12 or anything. It's wrong. Okay, thank
Yeah,
you.
yeah, 7 CR. Lo.
Okay.
Good job noticing that. Kyoko, so far so good.
This 12, right, or 14? It could be both. On page 10, though.
Not very. Okay, let's decide on one like yeah, well, but that's
Looks like 12.
Yeah, I think it's 12. Let's just pretend it's 12.
Okay.
Okay, general form, please. Good, Ines. Let's start. Looks nice. You can simplify root cert 544. Do you know how to do it? It's probably useful. I might as well just revise your cert a bit. If you don't know how to, please tell me.
It is my general too.
I'm okay, but you didn't do the in this power minus one. You say that you want to do it.
Oh, yeah.
Do you want to or do you not want to? What's the advantage basically? Don't just do it for the sake of doing it. If you want to do it for a good advantage. Kyoko, do you know how to simplify?
Mm.
Okay, so revising your cert a little bit, right? Look for perfect squares lah. Look for 1, 4, 9, 16, 25. Yada, right? Okay, so Ines looking good so far lah, right? Now separate lah. Hey, the behind one is 12. Come on, man. You're not an amateur in binomial. Come on, man. You even have your notes. The behind one is always power 12. Are you sure or not?
The behind one is
all the 13 guys is going to be power 12. Come on, cannot be right. Thank you. Separately. So Kyoko, we look for 4, meaning 544 divided by 4, right? or divide by 16. How do you look for it? I use calculator, of course. Okay, find one for us, please. Andrew, are you okay so far?
Yes, already finished. I'm pasting in the jumbo.
Okay. Times 16, very nice. Very nice. Which is gonna be 4 third 34. Now in 34, can we have another 1, 4, 9, 16, 25? Kyoko. Kyoko, in 34, can we have 1, 4, 9, 16, 25?
No.
And you know that because your mental calculation is not so bad. So we stop here. This is as simple as we go.
Mm.
Okay, good. Continue from there. You still have to find 4, right? Hopefully you get 6. Andrew, oh, you're pasting it there. I'm gonna put it in the previous page. Okay, so the F times 10 is definitely correct, right? Then the GP increase, right? The GP increase plus the K increase is 0, correct? Increase. And then the 160 is, the 160 is the transfer to negate the friction transfer, right? Okay, so your GP increase will be 6, 10. Yeah, correct. Okay. So do you understand? We are handling 2 transfer in, basically. Okay,
Teacher.
done by the. Yes, Anish?
Just to be sure, right, for indices, you can't multiply this.
You can only. What do you mean by multiply? Sorry.
It's,
No, you can. You can. The 2 and the 12 minus R can and should be multiplied.
Can.
Yeah, can and should. Yeah, that's still our basic. So Andrew, are you sure you understand this question?
Yes, I understand it now.
Cool. Now what do we do now? Do we continue with our chemistry? That's one option. Do we do the next chapter of physics, thermal? That's another one. Okay. I'm not sure there's another option. We can revise past chapters if you want to, but it's better to go to the future right now.
Yeah.
Okay. So
I think the next physics topic will be good because I heard from my teacher we're going to be moving on very, very soon.
okay, thermal physics then, yeah. So listen to me carefully. I will help you through. Ines, combine the x power. Combine the x power.
I was using my calculator. It's add, right? I add this.
It is add, yes, correct. Looking good so far. Okay, Kyoko, are you okay? Right. Kyoko, after this, we check the answer to the question. So Andrew, page 3, yeah. The next chapter is thermal physics. I give you the 2 formula first. Just give me 2. Andrew, Q is heat, not heat, is heat transfer.
Heat transfer.
And
What's the difference?
and the emphasis in transfer is another transfer. The 2 chapters are talking about the same thing. It's transfer. It's just that in this transfer, it will be from heat to heat. It's a very specific transfer. It's still a transfer. That's the point. The point is not the heat. Heat transfer, whatever, like heat, no? Transfer in the form of heat. So we transfer in the form of money. Maybe this one you transfer in the form of monopoly money or game money, whatever. It's still transfer. It's still transferring from one person to another person. You will still need force. It's just that you don't see the force here. The heat transfer does not seem to have a force attached to it. Okay, maybe that's what makes it different from work. Work will always have a force attached to it or doing it. But Q has somebody doing it. It's called conduction, convection, and radiation. Somebody is still doing it. It's just that it's not force. Do you understand what I'm saying, Andrew?
Yes, understand.
Okay, so the point is transfer. That's the point, eh? That's the point. Okay, so the transfer can be Q in or Q out. So the thing Q can be Q in or Q out. One more time, the heat is not storage. It's like totally wrong. It's not storage. It's transfer. Okay, storage is your wallet, your bank account. Transfer is, well, transfer lah. Ines, you're not very stuck yet. Good for you. Now, there are only two types of transfer in the heat sense. Only the first guy or the second guy. So what is that first guy? The first guy is very simple. This is your temperature. This is your temperature lah. This is your difference in temperature, right? This is just your mass, simple stuff. So your new guy is here. This is new. This is new. So an ice can go from, I don't know, minus 10 degree to 0 degree, right? Then
Yes.
water can go to 100 degree. Let's just say that. Okay. So, Andrew, the heat transfer when going from ice minus 10 to 0, right? Ice can be very cold, depending on our fridge, can go up to 0. So the first one will apply. Also here, it will apply. Whenever there's a change of temperature, of course, the first formula will apply. Of course. Nash, it does look good so far. It does look quite good to me. Yes. Quite proud.
I made an error, but 12C5 and 12C7 are the same.
I'm so sorry.
12C5 and 12C7 are the same.
No. You try something. You try something for me. Try 7C2 and 7C5. Just try. It's always symmetrical one.
Yes.
Yeah, the C's are symmetrical, so there's no error there. Good for you. Go check the answer key. Tell me whether you're right. So back to you, Andrew. Now, here's the physics. Listen to me. When ice hits 0, he will start to melt. The melting process is long. You know that when you buy a drink. Ice takes time to melt. It also takes heat to melt, obviously. Heat will absorb or receive a transfer in of heat, right? Receive a transfer in, and he will melt. During his melting, he is not changing temperature. That's physics. He is using the heat that he receives in order to melt, so to speak. Second formula. The first formula requires C. C is specific heat capacity, whatever that means. L is latent heat, whatever that means. I'm explaining you the bare bone. Let's maintain the bare bone. Okay, so far so good. Andrew, any questions so far?
Not really.
Okay. Ines, can I see the answer? I cannot see.
-2
Okay.
or +2, plus minus 2.
Is it possible? Oh, possible values. Nice. Good for you. Good, yeah. Now I'll try to do the next one, Ines. I know the n is not given, so try your best first. Okay. Good job for this one. Yoko, are you correct? Yoko?
Yeah, sorry. Yeah.
Okay. So ignore part 1 and part 2. I'll teach you very soon. Do something else to increase your morale first. You understand me? Okay. Andrew, the C, specific heat capacity. I'll tell you, the sea of ice is different from the sea of water. The sea of a material is different from the sea of another material. Even if they're the same H2O, if they're different form, it's going to be different one. The specific capacity is very specific in that sense. Whatever that thing is a very specific thing. Okay, that's what you must remember. They will tell you usually what the specific heat is. Just don't have assumption that water same with water or water same with something else. Water and ice different. Ice with metal obviously different. Okay. Same with latent heat. Latent heat will be different one for different kinds of things and different kinds of transformation. That's the most important thing to learn. Okay. Any other question? If there's no other question, Andrew, then that is the thing that you need to know. That's all. Okay. The rest
So
are
just
gonna be
which
very easy.
equation is for which situation?
You will need to be able to use the equation with your understanding. Okay. Okay. Now let's see what happened. So I'm going to show you. Yeah. Kyoko, you decided. Have you decided on the next question, Kyoko? Not yet. I know.
I'm putting on.
Okay. Ines, you're not starting the next part. Okay, even though it's a bit difficult. Why are you not starting?
I'm trying to understand what I can do first.
Fair enough. Fair enough. Remember though, no matter what n is, the general form separating to blah 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 is always going to be the correct step one. That's how boring binomial is.
Mm.
Okay, no matter what the question is, you end up doing that one. Andrew, I'm showing you a few questions for the thermophysics from an exam paper. Check it out in question page 4. So in question 4, in page 4, Andrew, the question 15 is from secondary 2 concept. It's a secondary 4 question, but it's from secondary 2 one. You shouldn't find it too difficult. Just check it out for now. Try to do it. Okay, Kyoko. The first one is proving, correct?
Yeah.
Would you choose to be stuck there?
Mm.
No, what do you do? Do part 2 first, Kyoko. I insist, yeah. Do part 2 first. In exam, do part 2. Okay? Not part 1. Anish, do something.
Okay.
Do something. Which is general term and separating them. That kind of thing.
I mean, they're entirely different questions.
They are not.
They're not
Please.
different questions.
Yeah, I keep telling you, yeah, no matter what binomial question looks like, the standard stuff is very boring one. Do the same thing. General term, separate.
Wait, hold on. How do I do it with 2 brackets?
I thought you have in your note attachment notes. You don't have in your note anything about attachment, is it?
I don't think we ever did a question like this.
Ah, my goodness. Okay. Just ignore the attachment for now. Put that in your notes. Just ignore the attachment.
But I mean, I don't know what to do. I don't think we've ever done a question with attachment.
Ignore the attachment. Did you hear me?
Okay.
Andrew, try to do question 15. Oh, you don't know how to do question 15.
Oh, I saw only. It's fine. I know how to do question 15.
Oh, try first. Then we discuss. Okay. Okay, Kyoko, so you are deciding to use it, which is 9. Nice. I think that's a good way of using it. Kyoko, good. Now, what will you do? Ines, are you stuck?
Yeah.
Okay.
No, not yet.
Unblock your mind. Ignore this. Got it. Okay. Do the standard thing. Come. Standard stuff. Okay, good, Andrew. So let's talk about it. So yeah, so good. Compress. Wonderful. Okay, your D is correct. Now, Andrew, for question 6. Now think carefully. Now, if the pot is made of insulator, then obviously it will prevent a lot of conduction. Nice, right? Until you realize that a pot made of insulator is not a very good cooking pot.
Oh, because it cannot conduct heat from the fire when it's cooking.
Correct. So D makes sense, but also not make sense. So you are thinking, but you have to consider the practicality, right? Just like chemistry, you have to consider the practicality. So try another answer. It is still a good thinking answer. It's just that it doesn't make a lot of sense. Good so far, Inish. Good, you're doing what you can. Let me see the power behind. Come on, you keep making mistakes there. The power on the third bracket. The power on the third component. Come on, man.
It should be.
You keep making that mistake. Kyoko, are you stuck? Kyoko, are you stuck?
No.
Kyoko, are you stuck? Okay, I don't want you to be stuck too much today. Please apply my hint. Anish, can I see? Yeah, that's an answer. Okay, separate them, please. Do you have a new answer, Andrew?
Oh, I'm guessing that it is B.
Yeah, so let's guess first. So now obviously C is wrong, yeah. So I mean C is correct lah, but that's not the correct explanation, right? So a very low specific heat. So surprisingly, yes.
Oh, sorry. I was asking the one, if there's like 1 to the power of n minus r, then is it 1 to the power n minus 1 to the power of r?
I'll give you a better answer. 1 to the power of anything is still 1.
I mean, okay, forget about the 1, then the x by 3. So if we make it 3 to the power of x to the power r, then I multiply it. So it becomes 3 to the power of rx. Then how do I split it?
Could you just split it to 1/3 times x? 1/3 times x, please, in the inside. Okay. So Andrew, the answer is very high specific heat capacity. Now, this is the first understanding I will give you. Specific heat capacity has an understanding like he can store a lot of things. That's your storage understanding. It's like I can accept a lot of heat. Low specific heat capacity, I can accept not so much heat. My wallet is big versus my wallet is small.
Oh, okay.
That's some understanding. I'm trying to give you the understanding. Good. So Ines, separate properly. You have separated. Now remember the 1 is always 1, so that's a simplification. The separation is good. Now you're going to write a note on the end. This is going to be your note, yeah, Ines?
Yeah.
Kyoko, do you know how to continue? Okay, you know. So Ines, so I'm going to give you something. So NCR is going to be n factorial over n minus r factorial r factorial.
It was this thing.
That factorial thing. So first of all, it is in your calculator. Okay, show me your calculator. Okay, so I'll tell you what it means. So 4 factorial simply means 4 times 3 times 2 times 1. 10 factorial simply means 10 times 9 times 8 blah 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 times 1. Understand?
Okay.
So for example, 12C3 will be 12 factorial over 9 factorial 3 factorial. You don't need this formula until now. Now, please confirm that this is correct. You can use your calculator to confirm. Now, Andrew, yeah, apologies. Yeah. Now, for 17, your answer is correct. Let's confirm one thing. D is wrong. Why?
Because pot needs to have good conductivity.
No. Question 17. Sorry, question 17. Question 17. Question 17.
Oh, sorry, question 17.
Yeah. Why is D wrong?
Because there is no like melting.
Correct. And melting is supposed to be a part where the temperature don't change, right? Part A is also wrong because ice and water has a different C capacity and their graph will be different one. So since I is low, it'll be faster. Since water is higher, it'll be slower. This is the second understanding on specific heat capacity. Does that make some sense? Because the wallet is big, it takes time to increase the temperature. Because the wallet is small, it takes less time,
Less time to
increase the temperature.
Oh, okay.
That's kind of the understanding of capacity. You get me?
Yes.
Okay, good for you. Now, give you another question. Ainesh,
Yeah.
have you confirmed that my formula is correct using your calculator?
Yes.
Okay, then you're now going to apply it here and the application will be a bit terrible. Okay, so you have a lot of notes after this. Andrew, try to do page 5. Oh, very good, Kyoko. You do a multiple answer, multi-answer. I like. This is the first time I see you do it. It's a multi-answer. You're doing too many multi-answer. What are you talking about? How come you'd have, what? How come you have 180 plus 30? What are you talking about?
Because there's 2 rounds, I thought.
Quadrant 1, quadrant 2, improve here. This quadrant 3, gonna be wrong. Understand? It's quadrant 1, quadrant 2, quadrant 5, quadrant 6. You understand what I'm saying? It's not quadrant 1, quadrant 2, quadrant 3, quadrant 4. No. Not making any sense. You're erasing your mistake. Okay. Not gonna complain. Okay. So Ainesh, now you have an NCR, which is very, very not, oh my goodness, yeah, the question is just not nice at all. Just not nice. Right? But I'll tell you what you can do. So he tell you the first 3 terms. Remember, what is the main thing about binomial question? He doesn't want you to do everything. You don't want to do everything, correct?
Yeah.
So what does the question maker do?
It gives you a power.
Like, or sometimes 3 lah, which is fine, right? The first 3 terms. The first 3 terms is very easy one. R equals to 0, R equals to 1, R equals to 2 lah, right?
Yeah.
Correct or not? You just have to make sure that it is an ascending power of x. So from your general term, which you have separated very nicely, make sure you have your 3 terms, your first 3 terms, and make sure that it is ascending. They are telling you the R. Use it lah. You're going to use it. Come on. This is them finding a way to tell you the R. Kyoko, why are you rejecting 390 and 510? If you're rejecting it, why do you include it in the first place, right? Correct or not? Okay, be careful, yeah? Andrew, do you understand the question so far? It is a rather long question.
I'm a bit confused.
Right. So let me emphasize what this chapter is. This chapter is about heat transferring in or transferring out. Correct? It's a transfer. In the month of in France right now, what kind of season is it?
Summer.
No, as in now you're correct. Actually, now you're correct. Actually, now you're correct. But according to this table, according to this table, what kind of season is France?
Autumn, slightly cold.
Slightly cold. So autumn, winter, don't know, depending on which region of France. Now, does this make sense or not? You have a warm water inside a box, inside a house, I suppose.
Okay.
Outside is winter. You want to maintain the house at 25 degrees. Okay. Does the situation make any sense?
Yes.
Okay. So from the water, heat will be transferred out or in?
In.
Wrong.
Transfer out. Because outside is
Out.
colder, inside is hotter.
Correct. Now the water is here, going to transfer into the house. Correct? Because the house will in turn transfer out into the winter. Correct?
Yeah.
You're just worried about this transfer, correct? Just this transfer.
Yes.
So QMC delta T or QML, do it. Anesh, show me your three first terms. Kyoko, are you checking the answer key?
Yeah, correct.
Good. Do you want to write notes?
Okay.
Good, Ainesh. Good. Very good. One is definitely one, right? NC0 is one. One power there is one. Oh my goodness, you're wrong. I'm so sorry. For R0, no, your R0 is correct. I'm so sorry. Your R0 is correct. I'm so happy. Now, R1. Kyoko, are you going to write notes? You think? Is it good? If this is not a good time to write notes, we'll continue. Is this a good time to write notes?
No.
And I noticed that you miss a lot of things, I have to help you a lot. Are you sure you don't want to write notes? I have to help you 3 times. Yeah, I have to help you 3 times here. The first question. I have to help you. Wait, how many times? 2 times. Yeah, I have to help you 2 times in the previous one, right? Again, are you sure this is not a good time to write notes? If it is not, let's do another question. You're right, Ainesh. Very good. You're very good. Good. I'm going to tell you NC2. Copy that. Go ahead. Tell you NC2. Andrew, have you decided QMC delta T or QML?
Right.
Come on, I give you 2 formulas. Use it. You're worried about the transfer out from water to the house. So QMC delta T or QML?
QMC.
Then apply, please. Ganesh, I'm giving you NC2, yeah? NC2, just wait. Slow, slow.
Sorry, I forgot what is M again.